this machine is infrared gas analyzer, and it is one of the most, or we can say, very important instrument in plant physiology, as by using this particular instrument we can measure several parameters which are related to photosynthesis and gas exchange. So basically IRGA can measure net photosynthetic rate, internal CO2 concentration, stomatal conductance, transpiration rate, as well as water use efficiency. So just to, in short, we'll discuss that how it works and what is IRGA, what are its components. So we are having Li-COR 6400. Basically it is a sophisticated portable gas exchange machine which is designed to measure photosynthesis and gas fluxes in plants. It has been widely used in plant physiology research due to its high accuracy, flexibility, and ability to stimulate various environmental conditions. Gas exchange techniques can be used by using IRGA, as it employed for decades as it measures carbon dioxide and water fluxes in leaves, and occasionally we can also use it in non-foliar tissues. Apart from these, it can also measure leaf physiological performances and photosynthetic capacities, offering insights into carbon and water fluxes in ecosystem functions. So we should have a basic idea that what is maximum capacity, what is flux, and what is conductance. So basically maximum capacity is the intrinsic photosynthetic potential of a leaf. It indicates maximum ability to fix carbon dioxide, as which it can be used to conduct photosynthesis in ideal condition. What is flux? Flux denotes rate at which carbon dioxide or water vapor moves in plant tissues during photosynthesis and transpiration respectively. It provides insight into dynamic exchange of gases between the leaf and atmosphere. This is the major principle, that it basically helps in measuring the exchange of gases between leaf and atmosphere. Net photosynthetic carbon dioxide assimilation, stomatal transpiration, and respiration rates are common fluxes which can be measured. What is conductance? Basically, conductance is described as a rate at which gas passes through stomata or leaf mesophyll tissues. We all know that basically the function of stomata, it helps in gaseous exchange. So by using this machine, we can measure that what is the stomatal conductance or what is the internal CO2 concentration in our sample. It can also reflect opening of stomata, affecting both carbon dioxide uptake and water loss through transpiration. Basically, conductance is a key regulator of photosynthetic efficiency and water use strategies in plants. So, what is the procedure or processing of IRGA? Basically, it has various components. So, firstly, it has infrared absorption principle. So what is infrared absorption principle? It is carbon dioxide and water vapor molecules which absorbs infrared light in a unique specific wavelength. Secondly, the amount of absorbed infrared radiation is proportional to concentration of these samples. As it's obvious that infrared radiations and gases which are, or the concentration of gases are inversely proportional. For say, if infrared radiation is high, so gases will be high. And secondly is the dual path detection system. This Li-COR 6400 employs two separate gas pathway. First one is sample path and second one is reference path. Obviously, we need reference as it has ambient air for comparison and it has unaffected leaf gas exchange parameter. And in sample path, basically it is our sample which we are going to use, and it is used basically to measure air from the leaf chamber where the plant is exchanging gas. This dual part design helps to correct for environmental fluctuation and it improves measurement accuracy, as we know that we are having a lot of environmental fluctuations. So this reference path helps to deal with this problem. Moving ahead, next one is gas exchange monitoring. So basically here, air containing carbon dioxide and water vapor from that leaf chamber flows through IRGA gas analyzer. The analyzer then detects the difference in infrared absorption between the sample and reference air. As you can see that in this diagram, it is clearly shown that basically it measures difference between reference sample and in sample IRGA. Next one is changes in CO2 concentration provide information about photosynthetic rates, while changes in water vapor concentration reveals transpiration rate. So moving ahead, next one is photosynthetic rate calculation. Basically, this system helps to measure net photosynthesis. It can be measured by using reduction in CO2 concentration between the incoming and outgoing air from the leaf chamber. As you can see that air in and air out, this can be measured, and we can easily measure net photosynthetic rate, internal CO2 concentration, stomatal conductance and transpiration rate. Next is water vapor and transpiration movement. Water vapor concentration are measured alongside carbon dioxide, enabling the estimation of transpiration rates. These measurements are crucial for evaluating water use efficiency under various environmental conditions. As we know that when plants are subjected to any kind of stress, then majorly photosynthesis and gas exchange parameters are hampered. So in previous tutorial, we have discussed about junior PAM. Junior PAM is basically used to measure for PS2 efficiency or PS2 activity. We can measure Fe by Fm value from there. But here we can measure net photosynthetic rate, internal carbon dioxide concentration, stomatal conductance, water use efficiency and transpiration rate. So this is most important instrument, and luckily our lab is having it, and it has helped a lot in our research. So what is the working principle of this IRGA? The gas exchange measurement using this Li-COR 6400 IRGA operates as an open system. It is basically an open system. The system uses two infrared gas analyzer to measure the concentration of carbon dioxide and water, one before the air enters the chamber as its reference IRGA, and another one is exit as sample IRGAs. By comparing these values and knowing the air flow and enclosed leaf area, the system calculates critical plant physiological parameters such as carbon dioxide assimilation, transpiration. This data helps to assess photosynthetic efficiency and water used under several environmental conditions. Basically, this figure is showing that this is the principle of IRGA, as I have told you earlier also, that IRGA operates as an open system. The concentration of carbon dioxide and water vapor which is incoming and which is also termed as reference IRGA, alongside with the air flow entering the leaf chamber, these parameters are then measured again by sample IRGA. So we will discuss it while I will demonstrate it that how it functions. So what are its application? So as you know what are its application, but in brief I am discussing it with you. Basically it evaluates photosynthetic efficiency under different environmental conditions. It studies the impact of light, temperature and carbon dioxide level on photosynthesis. Apart from it, it also analyzes plant responses to stress factors such as salinity, drought, heat and nutrient deficiencies. It also helps in selecting plant varieties with improved photosynthetic efficiency and stress tolerance. At last, it also assesses carbon assimilation and water use pattern in natural ecosystem. So what are its advantages? It have many advantages. So just in short, I will discuss. It is highly accurate and sensitive to carbon dioxide and water vapor measurements. Secondly, it operates as dual part design. As I have told you, it has reference and sample IRGA. Third one is it is portable and suitable for field studies. And lastly, it has real-time data acquisition and advanced analysis capacities. So basically, this is completely assembled IRGA which is used in field to measure various parameters. So I'll now demonstrate you that how this IRGA is used. So first of all, these are the so we are having different components of IRGA. So this is IRGA unit. You can see here it is having display. So everything which we are going to select or deselect, everything is done on this main unit. This one is leaf chamber and it have a sensor here, and after when it's open it also have thermocouple sensor here where we will be placing our leaf. Secondly, this one is tubing system. Basically, this tube is going to assemble in this inlet and outlet port, which is going to connect this leaf chamber and with this main unit of IRGA. Now, as you can see that these both units are de-assembled. Now, firstly, we'll assemble it. Assembly of IRGA is quite tough and it should be done meticulously because to make its airflow regular. So first of all, we are going to assemble this leaf chamber. This one is going to assemble here in this port particularly. Secondly, we are going to assemble these ports in these inlet and outlet ports. Basically, this helps in regular airflow. Now, this should be assembled in this port. As you can see, here are wire and here are holes. Now, very meticulously, we have to tighten these screws. Ensure that tightening should be done so that airflow is not, airflow is measured here or there is no leakage of air from here. Now, this particular leaf chamber is assembled with this tubing. Now, this leaf chamber is going to connect with this main unit. As in this main unit, you can have a look that we are having these ports, these inlet and outlet ports. So, obviously, these two will be connected in these two ports and these two will be going to be connected in these two. As you can see that this black one going to be connected with this black, here is the sign of this black, and this one to this port. Assembly of this IRGA is quite tough. Apart from this assembly, basically this helps in airflow. As we are not doing it in field conditions, So there would be hindrance in reading. Just you have to learn how to assemble it and how to measure readings from it. This is battery. So now I am going to connect battery with this port. So now our IRGA completely connected. If we are using it in field conditions, we can use this stand. Is this IRGA is having here where we can adjust this stand, but now we are using here in classroom, so there is no need to adjust this stand. So here we are having this switch. We'll switch on it. It will take some time to warm up or to stabilize. So we have to wait for 30 to 40 seconds. Again, this is controlled, this one is stressed, and this one is hormone treated. Fine. So now you have that idea. In stressed condition, photosynthetic or gas exchange parameters will be low. However, in hormone treated, these will be high. So let's see that what we are getting in it. So you cannot see in this display we are having three options. One is Arabidopsis chamber, second one is default fluorometer, and third one is factory default. Just you have to enter here because we want to use factory default system. Enter. Now processing is going on. Now they are asking, is the chamber IRGA connected? So you can see that chamber is connected. So there is Y or N. Y stand for yes, N for no. Just you have to click, select here Y. Again processing is going on. Now options which are coming here are welcome menu, configuration, calibration menu, new measurement, and utility menu. Obviously we have to take new measurement. So for new measurement is at F4 option. For example, welcome menu at F1, configuration at F2, calibration at F3, and new measurement at F4. So we have to select F4 button here. Now it is stabilizing itself. Fine. So we have to wait for few seconds here also. Now readings are in positive. We have to wait that for it to stabilize and become positive. So what are all readings are coming here are photosynthesis, CI is internal CO2 concentration, TR millimole, that stands for transpiration, then is relative humidity and all those parameters, you don't need it. So yeah. Now reading is it in positive. Basically you can see any one of the reading. As I am seeing photosynthetic reading, now it became positive. So we are ready to use it. Now how we can operate, or we have to click on add remark. Add remark is at fourth option, F4. Or we can say that we can click on F1, open log file. Then after open log file, we can name this file. I am giving this file name as Gyan, date 13/2/25. Then again you have to enter here. Now here is enter or edit remarks. Now what do you mean by enter or edit remarks? It means your treatment pattern. For example, if this control 1 is treatment 1, this stress 1 is treatment 2, and this hormone 1 is treatment 3. So T1, T2 and T3. Now you should note this in your files that which one is T1 or which one is T2 and so on. So I am naming it as T1. So just you have to open very meticulously this IRGA. You have to insert you have to remove this sensor as it detects sunlight, but here we are not having sunlight, so just I am showing you. Now you have to close this. Your leaf is inserted here in this leaf chamber. What you have to do, as I have already done T1 here, you just have to click on enter and wait for your reading to get stabilized. As readings are fluctuating, obviously we will not get readings what we can get in field condition because there is no sunlight, and on sensors we are having no sunlight here. For example, now we are getting photosynthetic reading as 13, so we can take this as reading. So you have to click 3 times on F1, then F4, again you can get next reading as it get detached because now again by entering T2 you can calculate next parameter. This one is T2. Now enter here, just wait for reading. Reading is in minus. Obviously photosynthetic will be never it will give its reading in minus, so we have to wait till it gets stabilized. Now it's giving its reading as 9, so we have to wait 3 times, press F1, then F4, then again same option came. Now we have to enter T3. We have to close it, we have to, now this one is T3, hormone treated. Just make sure that whole leaf sample is placed under this leaf chamber because inside it are having thermocouple sensors, okay? And there should be no dust particles or water in it, neither our reading will not come. And it can also damage our sensor. Again, now I am clicking or selecting enter. We are getting 24 here. So okay, fine. 3 times F1, then F4. So these are the readings. So now you may come in group of 10. Come this way. Plant to liya. Tough area. What's here? T3. Just you have to mark T4 here. Then open this chamber. ये डिटैच हो गया है, इसको यहाँ पे इंसर्ट करो हल्के से, करना है, करो इसको बंद करो, यहाँ पे एंटर कर दो, रीडिंग्स आ जाएंगे. Here we are having photosynthesis. You can see here clearly CI, transpiration. These are other parameters, flow meter. As you can see here, we are having S, CO2 S. S is for sample and R is for reference, as I have shown you earlier. Fine. So now reading is in negative. Just click on F1, F4. यूज करना है. बंद करो. बंद करो. T4 -19.9, वो 19.9, ठीक है. T5 next. Clear? You have to close it. After operating it, you have to close it. Neither your readings will get interfered. Because F1, F2, F3, F4. Basically, F1, F2, F3, F4 and F5 keys coincide with these blocks, or we can say measurements. For example, on F1 side we are having log day lane, on F2 we are having view clear, and on F3 we are having close delete chance, and on F4 we are having add caps lock. So if we want to select add caps lock, so we have to select key F4. There is no such tough task because this is not touch. If this is touch, then we can only touch and measure our. This one is photosynthesis. This one is internal CO2 concentration. This one is transpiration rate. Fine. This one is CO2 of reference. This one is having CO2 of sample. H2O water of reference. H2O water of sample. Fine. Clear? You can treat it with any kind of stress, any abiotic or biotic stress. You can take any kind of stress. For example, you know that we are having biotic and abiotic stresses, as our work is on abiotic stress, so you can take salt stress, heavy metal stress, drought stress, whatever you want to take, high temperature stress, low temperature stress. It's up to you, whatever stress you are taking. This plant is treated with chromium. Fine, heavy metal stress. And it completely depends on concentration, that how much concentration you are applying. More the concentration, more negative effect you will see. Fine. Okay, fine. These are basically bypass scrub. This is for basically this one is tightened, this one is for reference, and this one is for sample. You should not touch it. You should never touch it because it is already calibrated. If you move it or roll it, then readings will get hampered or interfered. As it is calibrated, so you should not touch it. You just have to operate here. You should measure readings here only. So, AGA is done. You should wait for some time to stabilize it. You can take it F, press 3 times. How? बंद करो, प्रेस करके बंद करो, लॉक करो. आई ना आवाज. दिस इज फॉर लॉक. ठीक है ना, पकड़ो. ये है ना रीडिंग्स. ऑब्वियसली अब यहाँ पे हैम्पर हो रही है क्योंकि लाइट नहीं पड़ रही है, पीछे जा रही है. कुछ नहीं यहाँ पे. 3 बार F1, then F4. नेक्स्ट सैंपल के लिए 3. ये सारे पोर्ट्स हैं यहाँ पे, ये ऑन एंड ऑफ बटन है। बंद करो, बंद करो। बंद कर देना है इसको। हाँ करो, बंद करो। लॉक हो गया, पकड़ो, पकड़ लिया। अब इसके बाद यहाँ पे ट्रीटमेंट 6 एंटर, रीडिंग आ रही है। अब एक बार जब ये स्टेबलाइज हो जाए, you have to wait for few seconds to stabilize. F1, then F4. Again, your readings will be noted. ठीक है? इसको बंद करो, बंद हो गया। Another most important thing is that you have to clean it regularly. As you can see that it is having dust particles on it, so you have to regularly clean it so that neither your readings will get hampered or interfered. एक बार इसमें कर, एक बार खोलो, लीव रखो। रखने के बाद एंटर। ठीक है, यहाँ देखो रीडिंग है अभी माइनस में, अभी ये पीछे जाएगी, स्टेबलाइज होगी, जा रही है माइनस में। ये आ गई हमारी 22.9। ठीक है, निकालो, बंद करो। ठीक है, आगे समझ। तुम उसमें लो, खोलो, खोलो, लगाओ, बंद करो।